All right, welcome to the Ravit Show. We're here at AWS Reinvent, and look who are with me. Max, you're back on the Ravit Show. Super excited to have you back.
Thank you, Rivets. We are super excited to have you here again. Thanks for visiting the booth. And just like last year, so I'm Max, CEO of PinCap. Super excited to be here.
Max, it's always fun chatting with you, and today we have a customer with you. Bo is here, who's the head of online infrastructure from Pinterest. Bo, welcome to the Ravit Show. Just a quick introduction. What do you do at Pinterest, and a little bit about yourself.
Yeah, sure. Thanks. It's great to be here. I'm Bo Liu. I'm the senior director at Pinterest. Our team is responsible for all the online backend system, including databases, cache, microservice, analytic platform. So yeah, thanks for having me.
It's going to be an interesting conversation. I love Pinterest. I use it a lot. So, Bo, my first question to you is I know, and we all know Pinterest ran on HBase for years, and now you've moved to core systems, to TiDB. What finally broke with the NoSQL setup that forced to move back to SQL? Can you share a little bit about that?
Yeah, that's a great question. I think the real break point was that when we realized that HBase just couldn't grow with Pinterest anymore.
Okay.
So we were running one of the largest HBase fleets on the planet. To keep it work at Pinterest scale, we had to build a lot of in-house patches. That means whenever we do a major upgrade, it's a multi-year project with huge risk. For critical data set, it's unacceptable. On top of that, the feature gap was killing us. For example, Pinterest apps were screaming for things that HBase doesn't have. For example, a distributed transaction, strong consistency, secondary indexes. So we had to build a lot of things at the application layer,
Yes.
which made the system very complicated and leading to a lot of naughty production issues. And then I think there was also infra cost. So to ensure the data durability for our data set, we had to run HBase in a primary and standby setup. Essentially, we have to have a three-way replication on each side that effective with 6 copies of data.
Oh, wow.
So the infra bill was
Massive.
exactly. So the infra bill was insane. So at some point, we figured that probably
Yep.
probably investing more engineering time in HBase is not a good investment for Pinterest. We do need something like some database with native support for SQL,
Nice.
for transaction, for secondary index. That would lead us to TiDB.
I love it. I love the story behind it, and obviously it makes all sense if you kind of, obviously feel you all want to scale, you all want to get to the next level. It was a no-brainer, and because I've been obviously chatting with the TiDB folks since a long time now, and I've been also talking to the customers. I guess I've also spoken to Atlassian, Databricks, other customers that you all have been catering to as well, Max. That also gets me to another question. First of all, I know we are here at AWS reInvent, and I see all the customers you all are surrounded by. Databricks right in front of me. I see Atlassian behind me, so which is great. Tell me about what happened for these vendors or these solution providers that made them choose TiDB. What was wrong with the whole databases?
Yeah, if I'm trying to find one thing in common, trying to express it in a single word, it would be scalability.
Scalability. Okay.
Yeah. So usually there will be multiple dimensional, scalability things. For example, data volume.
Data volume. Right?
You want a single cluster to handle petabytes of data, and also you want a single cluster to handle, millions of transactions, millions of QPS and TPS.
Right?
And also you want to, ingest your data quickly, like, very large batch ingestion, hundreds of terabytes of data you want to ingest into your existing database. You want to do like, cross data join things.
Yep.
And it will be very challenge for, many of the customers. As you have more customers, you need, better scalability. And you just, mentioned, Atlassian, there.
Just behind us, right?
Yes. So Atlassian need another kind of scalability. For example, Atlassian actually want to handle millions of tables within a single cluster. So in total, they have 24 millions of tables. You can imagine, right?
It's massive number,
Yeah,
right?
it's not
Yeah.
possible for any
Yeah.
other of the databases to store such amount of tables or schemas.
Scalability is the key word here, is what I'm kind of hearing.
Yes.
Right?
So metadata scalability is another dimension for the keyword scalability.
Yes.
So that's the key for different enterprise customers.
Right?
Yeah, I think that's something in common. The more users you have,
Yes.
the more challenges you have.
With the old
But
databases,
in common,
right? Yeah.
it's all about different dimensions of scalability.
Yes, I love it. These are fantastic insights, Max. Thanks for sharing that and letting us know about the different problems that they were facing with the old databases and how you all have kind of changed. Obviously, scalability plays a very important role for any business, and with the level of data that we are interacting with all the AI kind of coming together, it's unreal. Bo, I have another question for you, and
Sure.
this is a little bit technical in terms of for our technical audience, we wanted to
Sure.
get there. You moved the critical graphs like Zen to TiDB with no downtime and 99% consistency. So how did that double write migration actually work? How did you know it was safe to cut over? Because it's something which is a little bit thoughts that you would need after, right? So tell us a little bit more about that.
Yeah, exactly. So before we did the migration, our first thought was it was terrifying. So yeah, if you think about how critical the data is, so we looked at several fancy migration strategies. Some of them look clever on paper, but when it comes to correctness proof, it's terrifying.
Yes.
So in the end, we went with a simplest solution that could possibly work. Basically, it's double write plus continuous reconciliation. The basic idea was that we stood up a TiDB cluster in parallel, and then we took a snapshot from HBase and we store it in TiDB. And in the meantime,
Nice.
for every new change, we will apply it to both databases. And then we build a reconciliation pipeline which continuously monitoring the difference and automatically
Very important.
fix any difference found.
Yep.
So we do it in an iterative way, in multiple iterations. We measure the mismatch rate, we fix any bugs that we found, we increase the consistent percentage and repeat. So we keep doing this until we see the consistent rate is above 5/9. Then we know that the data in the new database is identical to the data in the old database. We feel comfortable to do the switch.
Yes.
So I guess the iterative loop is the key. So it's way safer than trying to build one perfect migration script. The general principle is that we are only confident to do the switch when we really see the data is consistent in the new database.
I love it. These are fantastic insights and great details for sure. Max, I know you also talk to a lot of customers, a lot of CIOs, and CIOs always ask for stability. AI teams ask for speed.
Yeah, for sure.
And my question to you is, how do you shape things like agentic AI and serverless without risking the core reliability with your big customers, because they depend a lot on that. So that is something I'm kind of curious to learn from you, Max.
Well, I see more and more in common from both traditional customers and AI pioneers.
Pioneers, right?
Yes,
Right?
and I think I see one thing in common is that they all want to move fast, and especially in the AI era, right?
Era we
so
are,
everyone
right?
wants to move fast.
Move quickly, right?
Yeah, so thanks to the disaggregate architecture of TiDB, so we can remove extremely fast. So you know what? We have some internal number. We are going to publish it later.
Oh, nice.
So currently, daily created clusters created by agents. What's the percentage? 90%.
90%?
Yes,
Wow.
hard to believe, right? So 6 months ago, it's about 15%. So within 6 months, so the user of database is
Yep.
not human anymore, right? So at the end of this year, it's going to be 99% of the database will be created by agents,
Agents,
and will
wow.
be operated by agents.
Yeah.
Humans still very important, right? We are going to be a supervisor.
Maybe an orchestrator that we are supervising all the agents.
Yes,
Okay.
but you do want to move fast, so you are not going to review all of the SQLs that generated by agents, right?
Wow.
So
Yes.
you want agents to review those kind of things. You want to make sure that agents can, supervise agents.
Right.
And so human is the last one who want to supervise,
Supervise.
agents of agents, right?
Agents of agents, right?
So it's so you have to move fast, whether what kind of companies you are, right? You still need to move fast.
With the stability, you have to move fast.
Yes, to keep up with AI workloads,
Yep.
right? So I think that's quite common. So the architecture is super important to help you to stabilize the core and move extremely fast on top of the core.
Right. It is
Yes.
something which is very important. But because I talk to a lot of CTOs, I talk to a lot of enterprise leaders, and the same thing that they kind of feel as well. Robert, we are in this agentic world, and this has also been a talk of the town here at AWS Reinvent, right? We need to be so careful if we're going out with in making sure where agents are actually working as co-workers for us. We need to make sure we're supervising it and making it the right way to obviously choose where and what technology we are using it for. So that's very important, and that's what I've been kind of feeling reflects well for what you kind of talking about. Bo, I have a curious question for you around, and a little bit technical as well.
Sure.
So AI data like embeddings often lives in separate systems. With TiDB as your new base, do you plan to pull over more AI workloads and like into TiDB, and or will you be keeping specialized stores for that? Because now we have options. So I'm kind of curious to know how are you kind of trying to manage that?
Yeah, sure. I think currently at Pinterest there are separate systems.
Okay.
But I believe like that is the dream we want to have. Essentially, you have a unified database supporting both transaction workflow and the AI workflow, consolidating the systems without the need to shuffling data all over the places. So I think that is something we want to have. So right now, I think for the recommendation of AI stack, it's very specialized. So we are not quite sure, like we are not there yet, essentially. We are not quite sure how the interface will look like, how a specific need should integrate with a generic platform like TiDB. So, and also I believe this is a fast evolving space. So we look forward to like how TiDB will evolve in this space, and love to see what TiDB can offer in this space.
Excited about this partnership and how that kind of goes, but it is also mature decision to obviously test things first and then go ahead in the game and obviously make it as easy as possible for the internal teams as well.
Yeah.
Max, one last question that I have for you is around TiDBX and agentic workloads, because we all are talking about it a lot.
Yeah, we are super excited about that. Yeah.
Yeah, tell us a little bit more about it. How is it going to help the enterprises and also the users?
Wow, cool. So you probably noticed that some of the pioneer agentic companies are using TiDB. For example, Manus. Manus is using TiDB.
Oh, nice.
Yes, and so and DeFi is using TiDB as well.
Okay, nice.
So we have inspired by our customers a lot, and we learn a lot from our customers. So those pioneer workloads are extremely helpful, and it is very important for for us to guide us to the right direction, to the the earlier use case.
Yes.
So one thing we learned from Manus that when we talk about agentic AI, what does it mean and how does it relate to database? What is the requirement for database?
Yeah.
And so TiDBX actually powered Manus. So
that's very cool.
There is a formula.
Yeah.
There is a formula.
Okay.
What we call the XYZ formula.
XYZ formula.
So
okay.
customers like Manus, they have X users, millions of users, X users, Y projects. So each of the user can create
so many projects.
Yes.
Yeah.
Y projects.
Right.
And for each of the project, you need agents
Agents, right?
within their projects to finish their projects.
Okay, so that's good. XYZ. That's where
Yes,
it's
it's
kind
easy
of
to
coming
remember,
from.
right?
Formula, right?
Yes. So, but if you times XYZ, X means how many users you have, right?
Yes. How many users?
It's millions, billions
Right.
of agents,
Right.
right? But some of the agents need a database, right? And they need to evolve
Yeah.
with the database.
Yes.
So when you evolve the database, you need to create a branch,
Yeah.
a database branch.
Branch, right?
So if something wrong, you can just go back, go
Oh,
go back
wow.
to any of the branches.
Yeah.
So that means you are going to have millions or billions of branches, database branches, right? That's what we call XYZ
Z.
formula
Yes.
for agentic native AI workloads.
I love it.
Yes, so we think it's a common pattern for these pioneer companies, and
Yep.
we think it's going to be a common pattern for all of the agentic native workloads. So that's what we see. It is very important. So TiDB actually try our best and move extremely fast to power companies like Manas, like DeFi,
Manas, right?
like other customers, right?
Wow.
To handle millions of databases and billions of databases.
In a easy formula.
Yeah, in the easy XYZ formula.
Yes.
You just can't imagine how much you should pay for millions of MySQL instances, Postgres
Totally,
instances.
totally, yes.
Right. You don't want to you don't even want to think about it.
Think about it.
Yes.
Right? Exactly. Let the agents do their work and making sure that it's in
Yes.
the easiest way possible.
Yes.
But having said that XYZ formula, I think you should get a patent for that one, Max.
Yeah, so we actually published the use case.
Oh, nice.
Manas. So you can search Manas and TiDB. You can see the
All the use case and how they're using it.
yes.
Oh, nice. I'm gonna check that out and also make sure that our audience is getting much more in-depth learning about how they're
Yeah.
utilizing it and how they're making SQL and the database is easy, right?
Yes. So thanks to those pioneers, help us to guide the right direction.
Right direction.
To evolve TiDB,
Right.
really quick.
Okay, Max. One last question for you and Bo. If people want to find you all, which is the best platform to follow you or reach out to you? LinkedIn, X, or any other social platform?
You can
Or
find me.
GitHub for you.
Yeah, for me, yes, exactly. I'm a huge fan of open source, so you can actually find me from GitHub. You can see my daily activities on coding things, right?
Yes.
I'm not really coding by myself, but leverage AI to help
Yeah,
me to
yeah.
do some prototypes. To
That's awesome.
Yes. So you can also find me via LinkedIn,
Nice.
yeah, or X.
Yep. Oh, all right. So all the platforms basically.
Yes.
Which is great. Bo, where can people find you?
Yeah, I believe LinkedIn is a great place to find me.
Okay, fantastic. So, guys, you all know where to find Max and Bo. Such an interesting conversation. Thanks for doing this. Really appreciate it. We'll keep the conversation going. And congratulations on this amazing partnership and customer vendor relationship. Thank you.
Thank you.
Thank you very much. Thank you.
Thank you.
Thank you, everyone, for joining us today.